Okay, cool. I think we can start. Welcome everyone to the first PyLadies Berlin Twitch stream. Um, my name's Mika. I'm a member of PyLadies Berlin, and I'm going to be the host for this evening. We have three talks this evening. One by Victoria Hodder, based on object-oriented programming in Python. One by me on functional programming in Python, and one by Mridu on memory addresses in Python. But before we start off, I'd like to just kind of introduce PyLadies Berlin for anyone who doesn't know who we are already. Yes, so PyLadies itself is an organization with chapters all across the world. We're a kind of international mentorship group with a focus on helping more women become active participants and leaders in the Python open source community. We want to do this by promoting and educating and advancing a really diverse Python community through things like education, outreach events, setup events, conferences, stuff like that. And yeah, we have PyLadies chapters all over Europe, Africa, the US, Asia, Australia, and South America. We aim to provide a really friendly and supportive support network for women to bridge a larger Python world. And anyone who has an interest in Python, we really encourage you to participate. If you're experienced in Python and feel like maybe mentoring people would be a cool thing you'd like to do, please do get in touch with us. For anyone who didn't know, there is a really cool PyLadies dashboard at nycpyladies.github.io/PyLadies/dashboard, which shows you all of our chapters, all of our members, which are about 54,000 last I checked. We're in 30 countries and 77 cities, so we are a pretty widespread organization. Yes, and with all of our participation, both in our Slack and in our events, we have a code of conduct, which is that we believe knowledge is for all, and at the same time, our events aim primarily to empower women in the tech community. By attending one of our events, including this online, event, you also agree to our code of conduct. Sorry, let me just boop. PyLadies is dedicated to providing a respectful, harassment-free community for everyone. We do not tolerate harassment or bullying of any community member in any form. And you can read more about the PyLadies organization's code of conduct at pyladies.com/code of conduct. Okay, so a little bit about us. We are the Berlin chapter of PyLadies. We were founded back in 2013. Before the COVID-19 pandemic and the lockdown that it has induced, we did regular monthly meetups with talks and workshops. We aim about twice a year to do full day workshops on lots of kind of disparate topics, from beginner Python topics to kind of advanced, kind of more kind of specific, maybe like sysadmin-y kind of topics as well. We do lots of setup events where we get people who haven't even used Python before to install it on their machines and set up environments and install packages and things like that. We also aim to connect people in the PyLadies network to companies if they're like searching for a job or want to move on to somewhere that they're connected to. And more or less kind of anything that we come up with, including Twitch streams, which is our first kind of experiment in this. And yeah, please, if you'd like to get involved with PyLadies Berlin, like if you want to give a talk or a workshop at something like this, or if you want to help organize meetups, or if you want to help coach at our workshop where you kind of guide Python users through a workshop and give help and advice and debugging. And if you really want to get really involved, you can always apply to join the organizing team and help us kind of organize events like this. Yes, this is for anyone who's kind of known us before. We had our own Slack, it's our own Slack instance for just PyLadies Berlin, but we've moved that now to the global PyLadies Slack. And throughout this event, we will be doing like lots of interaction on Slack as well, which I'll just talk about in the next step. But if you'd like to join, please go to slackin.pyladies.com and accept the invitation and join #city-Berlin. This is where all of our kind of Berlin stuff is happening. There's lots of general channels, lots of specific channels for other areas. So if you're not specifically in Berlin and maybe want to see what's going on in your kind of more local area, yeah, please join. And so yeah, so the format of this evening, we would really like your participation in our Slack, as we're a community that only really becomes alive when people are present. We're not like a kind of corporate tech conference. We do everything voluntarily, and what makes and breaks PyLadies is kind of the ongoing interaction with all the other PyLadies globally. So if you really want to get involved, please join the Slack that I mentioned on this page. Yeah, we would encourage you to join our Slack and our specific channel, City Berlin, if you'd like to access, for example, slides from this presentations and demo codes and stuff, and also just to kind of chat and talk about the presentations. Of course, you can also chat in the Twitch chat as well. And after the talks, there'll be space to ask the speakers questions. We would love you to do this in Slack, but of course, people will also be joining us on Twitch. And we will also, if I can get this to work, accept questions from the link above. Does it not actually show? Let's see. There we go. Okay. Yeah, so if you want to ask a speaker a question, please go to slides.app.goo.gl. I'll also paste this in the Twitch chat as well, just so that you can see. Okay, cool. And yeah, so a quick word about upcoming events. We have one event planned on the 12th of May 2020 about NLP, or natural language processing. We haven't finalized all the details yet, but once we do, that will be up on our meetup page, and you can probably you will be able to find out more information there. And lastly, would like to give a shout out to the Python Pizza remote event. For anyone who doesn't know Python Pizza, it was a format where it was a kind of like all evening or all morning, I guess, conference where each talk is 10 minutes in length. So instead of very long talks on Python, maybe 2 or 3, you instead get a whole range of short 10-minute talks on like lots of very disparate subjects, from very technical Python stuff to stuff that's not even really about Python specifically, but is maybe more about like how to manage open source communities or how to avoid burnout or things like that. And in this new online coronavirus age, they have also moved the conference remotely. So if you go to remote.python.pizza, you can buy a ticket for the first fully remote Python Pizza conference. And all profits, all proceeds from that will be going towards Doctors Without Borders, I believe. Yeah, so it looks to be, it's going to be a really cool event. If you'd like to really join in with the spirit of it, I can recommend also eating pizza on your sofa while you watch it. But yeah, so if you have any more interest in events like this, please go to remote.python.pizza and grab a ticket. Okay, yeah, without further ado, I'd like to introduce our first speaker. She's Victoria Hodder. She is a Python and Django developer who recently applied to Rails Girls Summer of Code and is working on a mental health open source project. And I will just pass things over to her. Yep, you should now be live.
Okay, let me check. You can see my slides?
Mm-hmm.
Okay, wonderful. Yes, thank you very much for telling me that. Why is it not? Okay, for some reason my slides aren't starting. Somebody help me. View. Maybe view is working. Why is it not doing this? I understand. Wait. Okay. I understand. Blank. Okay, whatever. We change the way we're doing this. It's not putting up my presentation slides, so we can just do it from here. They're still visible, I think, no? Okay, cool. So the title of my my talk is like what is an attribute? And this is the reason why I came up with this presentation was mostly from a source of frustration that I decided to solve for myself. And now I would like, from what I've learned myself, I now would like to share with you. So as Mika just said, my name is Victoria. I am nowadays working mostly with Python and Django. But actually, I did a history degree and I was a business English teacher to adults for 9 years. So I don't have a traditional CS background. But I started to work with code 2 years ago, and now I identify as a software developer using Python, especially. This evening, to define my purpose, like I said, I was feeling very frustrated especially with tutorials and things like Codecademy and HackerRank. I never really understood what they were talking about. And ultimately, what changed for me is I started to look into this thing called OOP. And the more I studied this, the more I understood what was going on. And now I feel quite confident when I go into applications like Codecademy because I actually understand the instructions, which from my point of view is a miracle. It's also useful. This kind of terminology is also nice to sound fancy in interviews, which I was also starting at that time. Was getting very nervous about the technical side, and again, decided to educate myself. So OOP is not, unfortunately, a Britney Spears song. It actually stands for Object-Oriented Programming. Okay, great. Now we know what the letters stand for, but what are the words standing for? So OOP is a programming paradigm, and a programming paradigm is a way of classifying a language based on features. And there are various programming paradigms. OOP is one. Functional, which Mika will talk about later, is another. There's also another called procedural. And Python, like many languages, takes many programming paradigms, but I am more familiar with OOP because of Django. And OOP then is when programs are treated as a set of interacting objects. And so the image that comes to my mind is this compass here, because it's like the code is orienting itself around objects. So it's finding its way around the code using the objects. So, good question. What is an object? It would be a good place to start, I think, when we're talking about OOP. And the spoiler is that everything in Python is an object. This includes every data type, including numbers, strings, lists, and dictionaries. These are all objects. And I don't want to go too much into that right now, but I have provided a link here where you can read a very, very nice Medium article about that, which talks about it in more detail. So since I don't want to talk about every single object type this evening, I think it would be nice just to narrow my focus, or our focus, into things like classes, instances, and attributes. And if you've never heard of those things today, before now, that's great. I've only just recently become very comfortable with them in this preparation for this talk. So what we're going to do is we're going to do some live coding. Yoo, it's not scary at all. And ultimately, this is the code on the left side, of course. I'm using Visual Studio Code. And then on the right side is my terminal. And this, at the end, this is what the code that we're going to look at together. But don't worry if that looks a bit scary. We're going to take it line by line. We're going to run into some errors. We're going to break some things. We're going to find out the names of things, and it's all going to be wonderful. So let's start. So this is a class. And if you want to have an empty class, so, and by empty, I mean like, I want to create this class and I don't want to use it right now, but I might need to use it later just to keep in my mind. So this purposes, I've called it empty. And if my terminal is working, so I need to go to OP. If I run this with nothing in it, I get an error. And it's a very unspecific error. But Mika, could you tell me what do I need to write inside of this class in order for it to at least run as a code?
Putting me on the spot. I think pass.
Pass. Okay, it's turning a funny color, so it should be. Okay, yeah, good. Thank you very much, Mika. Yeah, it's not doing anything, which is fine because it's an empty class, but it's also not breaking, which is a really, really good start. But this is not so interesting, actually. Having an empty class doesn't really do anything. So let's work with this class, which I created for you earlier. So we have a class called PyLadies. And here comes our first piece of exciting vocabulary for this evening. And we're looking at line 3, this category equals Pythonista. Don't worry about this /n. This is just to create some space in my terminal later because there will be more and more lines. This is creating a new line after this thing. So this is what is called a class attribute or class variable. I call them class attributes, but you will also read tutorials and blogs which are calling them class variables. They're the same thing. No need to worry about that right now. So let's see what happens if I run this. Again, nothing, but that's fine. I also did not expect something, but it also is good because it is not breaking. Good. Let us build on this. So let us create our first method. Now, some of you who have been looking at Python a bit already might see this def and go, that's weird. Like, isn't that called a function? Why is she calling it a method? And in fact, actually, you would be right. If this was outside of the class, this would be a function. And again, this is something that Mika is going to be talking about more later. But for my purposes of this presentation, this function now belongs to the class, and therefore we are calling it a method. And this method is very special because it is an init method. And the clue is in the name here. Some languages might also call it a constructor, so maybe that will be more of a familiar word for you. And then we have this word self, and you'll see this a lot in this talk. And self, according to my notes, is when we create methods in a class, so this thing, we receive the instance as the first argument automatically. So this is basically referring to itself. It's referring backwards. And if this is all a bit crazy terminology for you, just remember you have to put self in. If you don't put self in, we'll see later, it doesn't work. So just put self in and everyone will be happy. But I don't just want to talk about the instance. I also want to define these things: name, strength, and job. And these are all called parameters or arguments. Again, different people call the same thing different things. So I'm covering as much as I can in our time together this evening. So then we need these wonderful things here. We want to talk about the instance attributes or the instance variables. And this is where we kind of just set up the code which is coming after this method. So you'll see self.name, self.strength, self.job. These are called field names. And this name, strength, and job is referring to what we have here at the top. So these are the values of the field names. Good. So again, I can run this and still nothing happens, nothing breaks, but also nothing happens.
Hey, we're back. Sorry about that. Yeah, go ahead, Victoria.
So yeah, as I was saying just before, this is the init method. And then we have these arguments or parameters here, self, name, strength, job. Then we have the field names, self.name equals name, self.strength equals strength. And so this name, strength, job on the right is referring to here at the top. And these field names on the left, this is what I'm going to be using later in the code, in later methods. And now we can start to do some things with this code. We can start to do some exciting print statements. But in order to do that, first I need to instantiate the object. So I'm creating two variables, Victoria and Jane. And then I'm making this equal to PyLadies, which is the class up here. And then in the brackets, we have the name, strength, and the job. Note we don't have self here. That's because it gets passed automatically. You actually, when you're instantiating objects, you never have to write self in. It's just very important to write self in the methods in the above. Okay, so let's print out. Let's access the class attribute. And I want to print two statements. So Victoria is a Victoria, going back to the variable category, which is the name I've given to my class attribute, and the same for Jane. So Mika, could you tell me what would be printed out if I run this code now?
I would say Victoria is a Pythonista and Jane is also a Pythonista, I think.
You are correct. Yay! I don't have any gifts, but I'm waving my hands. You can't see me, but later, when in person, we can see each other again. Great, cool. Let's build another method here. So this is still going within the class, and it's being annoying, so I'm going to do that. So this is called an init method or a constructor, and this is called an instance method. So again, I've written here in the notes, this is a function that is associated with a class, like I was saying before. And so I've decided to come up with a method called skills. And remember, we have to pass in this self here. And when I run this method, I want it to return the statement name is a job who is really good at strength. And you notice we have this self dot stuff that we've already put up in our init constructor. Cool. So let's write a print statement using Victoria. Hang on, I need to check I'm writing this correctly. Ah, here we are. I think it's better when I use it like this. But let's comment out this code as well so it doesn't get too confusing. So now I'm going to call the instance methods. And the way that we do this is, I just want to change this actually because I want to try something out I tried earlier and see if it's doing the same thing. So we have printing this. So Jane dot skills. So skills is going back to the method, and Victoria dot skills, like the same with the category. So this should totally work, right? If I run it, okay. This is interesting. So don't be scared of this. This is not an error. It's not doing what I want it to do, but it's not an error. It's just telling me where it's coming from. And this thing on the right here, these are a memory address, which is something that Merda will talk about later in her talk, which is also very interesting. But this is not my print statements. This is not what I wanted. So Mika, could you tell me what should go in these print statements in order for this to work for my purposes?
Yeah, sure. You'd need to actually call the functions by essentially putting a pair of empty brackets after skills, just to like call the function.
Okay. Cool. That's weird, but whatever. Python. Let's see. Yeah, now it's working. So Jane is a data scientist who's really good at Keras, and Victoria is a software developer who's really good at Django. Yay, more cheering. So let's comment this out and write another method. And let's make this super easy. Let's make it super easy this time. Let's just do this. So my new method is called typing. I'm passing in self, and I'm returning name is now typing. And because we're like total pros now, we don't even have to look in my notes. Ooh, has to be spelled the right way though. And yes, we put the brackets in. We've put that in. Oh, should be good. Ah, thank God. Yes, Jane is now typing. This has worked. It's great. Okay, now I'm going to show you what happens if you don't put self in, since we're there. By the way, this is something I really encourage you to do. I really encourage you to break your code so you can see what doesn't work and why. And it really helps you to avoid mistakes in the future. So we get an error, as I expected. And specifically, we have a type error. So typing, in brackets, takes 0 positional arguments, but 1 was given. Well, that's a bit weird because from my point of view, none was given. But anyway, whatever, we have to put the self in. This is one of the most ambiguous Python errors I've ever received. But knowing about the self thing really did save my ass in quite a lot of projects. So if you get that error, there's probably something wrong with your arguments. Possibly you need to put self in somewhere. But so now we know, and it's easy, and we're professionals. So let's make an even better method. Oh, now I add more arguments. Okay, so our last but not least method of this evening is going to be called learning. And I'm passing in self, and also now I'm passing in subject, because subject I did not define above. So I will put it, I did not define it above. So now I put it in as an argument here. And I would just put in name, loves to learn about subject. Cool, easy peasy. So let's go further down. How do I do this? Okay, so we have the print statement. Then we have Jane, and then we put in learning, my mistake, and then we put in the brackets. So this should be fine. And we'll do the same for Victoria. So we've got self in, we've got the brackets. Oh, that's interesting. I've not closed my speech marks. Yeah. Okay. it was telling me. That's what the little arrow, the little carrot head is there telling me where I've made the error. And this is why I love Python, because it's very explicit. Ah, yes, another error. Great. But you know, this is an error we've seen before, because we saw this type error up here, and we're seeing the same again. So possibly, definitely, we're making a similar mistake, and it's telling me something about subject. And because you see, I've put subject in here, but it doesn't know what subject it is. You know, I haven't talked about it in here. I haven't talked about it up there. So I need to write it in. So probably within these brackets here, probably. And Jane is a data scientist, so I guess she loves learning about statistics. Yeah, I think that's how you spell it. Let's clear this screen because it's a bit messy now. And now it's working. Yay! Oh, it makes me so happy when things work. And let's comment this. Let's uncomment this, in fact. And so then we can see all of our print statements together. Wonderful. Okay, so that's the end of the live coding section of the talk. As Mika said, these slides will be in the Slack channel. And there's quite a lot of slides that I didn't go into because I decided to do a live coding. But I'm not sure how this is pop quiz going to work now since the... now it decides to work. Okay, whatever technology. But now I can do my pop quiz. It's totally going to be cool and fun. So the way this is going to work is we have this code that we went through today, and I'm going to ask you as an audience, as a collective, what I will say some things, and I would like you to tell me what the name is, but you're not actually going to tell me because I can't hear you. So the way I'm going to do it is I'm going to ask you a question, and then I'm going to wait a few seconds, and you get a chance to test yourself, and then I will reveal the answer. So this category equals Pythonista. What did I call this in the presentation? Bing! You are correct. It is a class attribute or a class variable. Okay, this def __ init. What's all this going on? What's that called? This is an init method or a constructor, depending on which language you're speaking. And this self, name, strength, job. What are these? These are parameters. I don't know how to say this actually, or arguments, depending on what you want to, what word you choose to take or which argument you choose to follow. Yes. And then the self.name equals name, strength equals strength, blah, blah, blah. What are these called? These are called work. Instance attributes. You. And a final question for this evening. What are these def skills, def typing, def learning? What are these called? These are called instance methods. We've reached the end. So as a summary, we have learned about what is OOP and what it is standing for. We've learned some basic terminology. We've learned that basic terminology is quite complicated when people take different names for things, but we learn and we live with this. We've learned how to write a class, and we've learned how to play with that class. And I would love to hear from you in Slack or in the questions if there's something that particularly resonated with you, or something, or you had an aha moment this evening, or you have actually another question because you're totally confused by what I'm saying. we will be on Slack, and I will be really happy to help you as much as I can. If you want to read more about this, which I highly recommend, for blog posts, I really, really recommend Programmers, because it's really concise and very well written. In terms of video series, I'm more of a YouTube tutorial person. Corey Schaefer is, I followed for a long time for any sort of Python concepts. And Socratica is not only educational, but also extremely, extremely entertaining. And the links for all of this are in the slide. So I would like to say thank you and that you're awesome. My contact, if you want to contact me, of course, you can go through Slack, but you can also contact me directly via email. You can find me on Twitter. My handle is A Difficult Woman. And actually, the big surprise and gift from me is that all of the code that we've written together this evening is also on Git. So I highly recommend that you do a Git clone of this and pull this from GitHub. I'm not using any dependencies. You just need Python 3 and it should run on your system. So that's it from me, and really enjoy the rest of the evening. Bye.
Thank you, Victoria. We actually have a question from the audience. If you're prepared, if you'd be okay with answering it.
Absolutely, yes, please.
So Pooja says, how are instance attributes different from class attributes? And can a class attribute be reinstated inside an init method?
Okay, the second bit I didn't understand, but maybe someone else can help. But let me go back. Where is oh, can you still see my screen?
Mm-hmm.
Yeah, cool. So from my understanding, a class attribute, let's make it bigger. The class attribute is something that's defined within the class, and then an instance attribute is just something that is within the instances. But that's a good question. I don't know. Is the honest answer to that.
Okay, cool. Thank you. We also have another question from Pooja, which is, does self refer to Jane when you do jane.typing when the declaration is typing self? So like when you call self with a specific object, what is self in that context?
What is self? I think this is the instance. And by the instance, I mean this part here. Self, to be honest, is still an area of mystery to me. So again, I don't know. I'm not an expert in this, but I really enjoyed learning about the foundations for it and continue to learn about these things, I think.
Cool. Awesome. Well, yeah, thank you so much for your talk, Victoria.
My pleasure.
Cool. So yes, so we're running a bit behind schedule because I had some technical difficulties. But if there are no more questions in the chat or in Slack, which it doesn't look like. Okay, cool. So then I guess we can move on to the next talk. First, an intro. Oh, sorry, getting a bit click happy. So kind of an introduction to me. Yeah, my name's Mika Nela. I'm a senior software engineer at Crate.io here in Berlin. Among lots of other things, I'm into functional programming, cybernetics, and body horror, as well as Python. And my talk for today is called Functional-ish Python. So yeah, let's get started. So if I would help if I click the button. So like, what actually is functional programming? It can be kind of a bit difficult to explain, especially if, like me, for the longest time, your only kind of experience of kind of programming paradigms in general is object-oriented programming. So in an effort to kind of explain it, I'll try and kind of outline the vibe of it. Oops, sorry. Okay, there we go. Sorry. I'll try and kind of outline the vibe of it by comparing it to object-oriented programming and kind of show where they are quite different. As Victoria explained, objects are instantiations of classes, and classes are kind of like blueprints that define what attributes an object has and what methods that object has to change those attributes. So for example, here we have a class that I've just kind of outlined. It has three attributes called name, age, and barking, which is just a Boolean of whether the dog is barking or not. And it has a function called toggle bark. And you can create an object from that class, so we can instantiate an object from that class. And for example, it's called Fido. Its name has a concrete value now called Fido, age is 5, and barking is false. So an object in this way is a kind of instantiation with concrete values for its attributes of a class, which is a kind of blueprint. In essence, we can kind of think of objects as having a state. That is, during at any point in time during the execution of your Python code, the object can be described by the condition of its attributes. So for example, if we called toggle bark on our dog object, the attribute changes barking from false to true. And even though the object is the same, it's the same like variable, it's the same pointer in memory, the state has changed over the course of the program lifecycle, essentially. And object-oriented programming is kind of all about states. When you write in object-oriented programs, you try to create these stateful objects that are described by these attributes, and then you can call functions on those objects, on those states, to change those states, to mutate them. And then you kind of have these stateful objects interact with other stateful objects over time to get to essentially the set of states that you want your program to have. And that's kind of like, in a kind of very abstract way, what a lot of object-oriented programming is all about. So with object-oriented programming, the main kind of focus of it are stateful objects. These objects, they exist throughout the course of a lifetime of a program, and they mutate depending what functions are called on them. By contrast, functional programming is all about stateless functions. It's all about functions that avoid state entirely by defining a program as a set of deterministic mathematical functions. But what are functions? I'm going to gloss over this really quickly from a kind of pseudo-mathematical kind of view. Essentially, a function is a relationship between a set of inputs and a set of outputs. That's kind of a bit abstract and kind of difficult to relate to programming. So let's demonstrate this with a kind of example. So let's take this function, f of x is equal to 2x. This is just a kind of general mathematical annotation of a function. The f denotes it as a function. It says it takes x, that's the value within the brackets, and the definition, the function body, is that it returns 2 times whatever the value of x is. We can implement this in a variety of programming languages. On the top, we've implemented this in Python and just called the function double. It takes in an x and returns x times 2. On the bottom here is the same function written in Haskell, which is a functional programming language. The top line is essentially a type annotation. It says that the function double takes in an integer and returns an integer. And then the second line is just a kind of definition of the method. X is equal to x times 2. So this is in essence what a function is. It's a kind of mapping between a set of inputs and a set of outputs. So our double function can be kind of thought of as this way, where the set of inputs are all the set of integers, and the set of outputs are also the set of integers, and the relation between them is this doubling thing. So 1 is related to 2 through this function, 3 to 6, 8 to 16, 10 to 20, and so on and so on. And when you write functional programs, you aim to write them so that they're composed entirely out of these functions, out of these relations between a set of inputs and a set of outputs. Functional programming lets you write deterministic code that's easier to understand and easier to think about ultimately, which is kind of like why I really like working in it. It's a lot easier to think about the code that you're writing and the code that you're reading and how that code interacts in general with all the other code in your project, for example. Okay, phew. We've very, very quickly and glossily defined functional programming. And now to move on to actually programming functionally in Python, right? Well, we need to kind of hold up and kind of check ourselves a little bit because ultimately Python is not a functional programming language. It doesn't really have all the syntax support or the underlying features to support programming entirely in like a purely functional way. And a lot of what Python does is based on mutability, which is again kind of quite difficult to do in Python, which is, a bit of a bummer. But there is hope. Python does have many elements taken from functional programming, and certain idioms from functional programming can help us write nicer Python code, even if we can't do it in a purely functional way. I'd like to quickly mention over the course of this talk two big concepts that I use in my day-to-day Python that I've taken from functional programming. And so all the examples from now on will be using Python and not any other functional language like Haskell or Clojure or whatever. So the first concept I'd like to kind of talk to you about is pure versus impure functions. Pure functions are like the double function that we defined here, in which they're entirely deterministic on their inputs and have no effect outside the function itself, and it doesn't change the arguments you give it. So you can see this double function, all it's doing is returning twice whatever it gets in. It's not mutating anything. It isn't causing an effect outside. It will always return the same answer if you give it the same inputs. And this is a kind of hallmark of pure functions. So yeah, essentially what makes a function pure is that it relies on arguments, which are known inputs, and only results in return values, which are outputs determined by those inputs. An impure function, on the other hand, has two things it can have one of two things. It can have a side cause or a side effect. A side cause is something from outside the function that affects its behavior. And side effects are where the function has effects outside of its parameters. So for example, side causes can be stuff where, for example, math.random is an impure function because it relies on something outside of the arguments you give it because you don't give anything to math.random. It relies on kind of other kind of system features to return a random number to you. In fact, if math.random was a pure function, it wouldn't be very useful because it would always return the same argument, which is kind of the opposite of what you want from a random function. Pure functions are lovely. They're really nice to think about, and everything they do is entirely reliant on the arguments of the function. They don't affect the program outside of the function, which makes them a dream to unit test, as you can basically map a set of inputs to a set of expected outputs to the function without worrying about mocking things or making sure the external state is in the right condition to test. And as a kind of side note, pure functions are lovely to cache because one additional benefit of a pure function is that it will always return the same value if you give it the same arguments, which means that if you have some kind of function that does a lot of expensive computation but is pure, you can cache the results the first time round and just return the cached results if you call that function again with the same arguments. You can't really do that with impure functions because there's no guarantee with an impure function that the results from the function will be the same if you run it with the same arguments. Side causes and effects are also very common in Python because the thing is, when I write Python, a lot of what I'm doing is modifying external states and getting information from sources outside of a function. For example, I might read data from a REST API on the internet, modify that data, and then save it to disk. And apart from the modifying of the data, everything else is an impure function. But the way I try and apply this principle in Python is that I try and quarantine Topical. The impure stuff of the function, for example, reading from a REST API and saving to disk from the pure stuff. So for example, I might have this impure function where I'm doing some code at the top to read from an API. The stuff in the middle is just processing the results, and the last one is writing those results to disk. The way I would kind of apply this principle to that is I would define a pure function that takes in an argument of results and processes them and returns them. And then I would call that from the impure function. In this way, the kind of meat of this function, the processing, I can then deterministically unit test because it's now pure and is always reliant on the arguments that it's given, rather than the impure function where maybe the website is down and maybe the disk is busy. Things might behave differently if you call it multiple times. And yeah, so I would actually like to also follow in Victoria's footsteps and do a little bit of live coding if I can. Okay, cool. Yeah, so here I have just some Python code. For this example, we're just going to say we have a list of names and we want to generate a list of greetings. So we have this function impure greet. This is just kind of, if you've not seen this before in Python, this is a, what's the term? List comprehension, which basically says we want to return hello plus the name for every name in the names list. And then we return that greeting. So we could do this now in the side. We can just do impure greet and call it. Oh, sorry, I need to run this. Cool. So impure greet returns a list of greetings. Hello PyLadies, hello Mika, hello Twitch.tv. And we want to also define a function that adds a new name to this list of names. So we can do impure add name, and we'll say world, for example. And then we can call the impure greet function again, and you see it returns something different this time, even though we've called it with the same arguments, no arguments. And this is because both of these functions are impure. For example, the impure greet function has side causes in that it relies on names, which is defined outside of the function. So anything in our program, in this case, this impure add name, but if you have a big project, it could be anything, can mutate this list, change its value, and this function's behavior will change despite us not passing any different arguments into it. Similarly, the add name function is also impure because it's mutating the names list. Like notice it's not returning anything from this function. What it's doing is it's mutating this list in place. So the function is actually causing an effect outside of it, which is to mutate this list. And so these are both very impure functions. They're quite simple examples, not very consequential, but if these were more kind of important functions in your Python code, you might not want them to be so easily dependent on things outside of their arguments. So we can rewrite these in a kind of pure way. So we'll just create a new thingy, and we'll define a pure greet function. And we'll just give it the same body as this one, so we can kind of iteratively purify it, as it were. So the first thing that we know about pure functions is that the behavior should always be dependent on their arguments, but pure greet doesn't have any arguments. So what we'll do is instead of saying it relies on a list outside of the function, we'll pass that list in. So we'll just give it a list. And so this way, now it is a pure function because it's not dependent on this list anymore. It's dependent on whatever list of strings that we pass into it. And then it returns it. Yeah, and now let's purify our add name. Let's give it the same body. Okay, cool. So like I said, first things first, we should not have any side causes for this function. So we need to add in names as an actual parameter to the function instead of relying on something outside of it. So we can just do that very easily. Oops, sorry. But it's still not a pure function, and it's because it is mutating one of its arguments, which is kind of a forbidden thing of a pure function. Unfortunately, in Python, especially with lists, there's a lot of mutability. And what this means is that in functional programming, a lot of data structures are immutable, which means that you can't change them. If you want to add a new element to a list in Haskell, let's say, instead of modifying the list in place and it being the same object, as it were, you create a new list from the old list with the new element appended. This way that you don't have this kind of mutating objects floating around your code. And so we can do something like that here. So instead of mutating whatever names is, we will create a new list with new name appended to the end of it. So we're not changing or mutating anything. And to do this in Python, you can do this. We can return the list of names plus a singleton list with one element of new names. New name, sorry. Okay, let's run this now. So let's have a look what names is. Names is just our three names that are predefined in the file. If we call pure add name now with our list of names and the new name, it returns a kind of new list with world appended to the end, but crucially, it has not actually. Come on, REPL. Crucially, it's not actually. What's going on here? Oh, crucially, it's not actually mutated the list names at all. When we want to change this now, we have to do it explicitly. There's no kind of implicit mutation going around. There's no explicit assigning. So we can do names is equal to pure add name, pass in the names, pass in world, and now names is what we want it to be. And now we can call pure greet with this list, and now it returns the greeting. And now we have no side causes, we have no side effects. It's all nice and pure. Okay, cool. So the second concept I want to talk about are higher order functions, and I'll just quickly kind of blitz through this. So a higher order function is a type of Python function or function generally that either takes another function as an argument or returns a function as a result. Higher order functions are super, super powerful and flexible. And with them, you can write really modularizable and flexible Python code. And in fact, you've probably likely encountered higher order functions before in Python. If you've ever used function annotations, for example, if you've used Flask or Django, you've probably encountered these before, where you use an @ symbol and then the name of a function to decorate an existing function. The name that decorator function is a higher order function that takes in whatever you're decorating as an argument. And so again, I like to do a little bit of live coding to just kind of demonstrate this. Cool. Actually, let me just close this window. Okay. Cool. But first off, I want to just point out that one of the requirements of a higher order function is that one of the requirements of a higher order function is that functions are first class objects. And what this means is that for a language to support higher order functions, functions need to be treated the same as an integer or a string or any other object. And you can see this here. We have this long greet function, which just takes 2 seconds and then returns hello and whatever name you give it. If we do long greet, again, I forgot to run it. Okay, so I can do long greet, and it points to a function. And if we call this and we say world, let's say, it takes 2 seconds to run and returns hello world. And because functions are first-class objects in Python, you can assign that function to an object, to a variable, sorry. And now you can see we have a variable which points to this function, and we can call it in much the same way as you would call a function. And so this means that we could pass a, or just the function itself, into another function as an argument, the same way that we could pass in an integer or a string or anything like that. And so let's say for example's sake, we want to time this function. Let's say actually we have in our project, lots of functions that take quite a while to run, and we want to create a kind of general profiling function that, given any arbitrary function, will tell us how long it takes to run. And we can do this with higher order functions. So let's define a time function that takes in as a first parameter a function, and then arbitrary keywords and non-keyword arguments. If you've never seen this syntax before, this is just a way of defining a function to take an arbitrary number of arguments and keyword arguments, and you'll see why we do this in a sec. So if we want to time a function, what we can do is we can take the time before we execute it. We can then execute the function, assigning the result of it to a result variable because we want to return it. And we'll execute whatever function we're given with whatever arguments we're given it. We'll say end is this. Oh, come on, Rebel. And then we'll say print function took end minus begin seconds. And then we'll return the result from this. And so what this means is that we've defined a function, a higher order function, that takes in any function as an argument and a set of extra arguments and keyword arguments, takes the time before we run it, runs the function, takes the time afterwards, and tells us the results. The difference in time. So, for example, we might want to see how long converting an integer to a string takes. So we can do time function. We want to pass in the string function, and we'll pass in the argument we want to give to string, which is the number 10. And we get the result, which is the string 10. And we also get a print that says function took 6.6 e minus 06 seconds. This essentially just means it took a very, very short amount of time. And because time function is a kind of general higher order function, we can pass in any function we want to it. So if we pass in our long greet function and the argument world, so we get hello world, and we get a string, a console print that says that it took 2 seconds and a little bit to run. So this is kind of like the power of higher order functions, is that you can write really generalizable and really kind of extensible code. But one of the things that I mentioned about higher order functions is that you can return a function from a higher order function as well. So we can go kind of an extra step here. We can, instead of doing this, which is kind of a weird syntax to give it the function and then the arguments you want to call it with, we can create a higher order function that returns a wrapped version of our original function. And I'll show you what I mean. So timed function, and this only takes one argument, the function. And within it, we'll define a wrapper, which takes in any arguments and keyword arguments. And then within this sub function, we'll do time. Result is equal to function args quarks. End is equal to time. Print f function took end minus begin seconds. Return result. And then from our higher order function, time function, we will return this wrapper function. So what we're doing here, we're defining a function that takes in any function as an argument and returns another function that runs that function argument and times it. So what we can do is we can, for example, create a version of long greet that is timed. So we'll say timed long greet is equal to timed function long greet. Again, forgot to run. Timed long greet is equal to timed function long greet. And here, it's now returned another function, which is a timed function wrapper at some memory address. And now we can call this long greet, timed long greet rather, just like we would call the original greeting function, but it's now timed, which is, I think, a really super cool use of like higher order functions. Yeah, so ultimately, I really, really love pure functions and I really, really love higher order functions. They have really kind of substantially changed how I write and think about Python code. And sure, there are some downsides. Python isn't a functional language, so to write in a purely functional way in Python is very difficult and actually makes quite ugly Python code. But functional programming has really enriched how I think about programming in general, and especially how I write Python. So, kind of in summary, I want you to be aware of what pure and impure functions are and try and make pure functions whenever you can. That way, they're easier to test and ultimately to think about when you're writing Python code. Secondly, higher order functions are very powerful and let you create very extensible and modularizable code in Python. Thirdly, familiarize yourself with the functools library. There is a core library in Python. You can just do import functools. It includes a bunch of higher order functions that are really useful for writing functional-ish Python, including having a cache for pure functions and a way of implementing partial function application, which is also a really cool functional programming feature that I don't really have time to go into. And most importantly, try out a functional language. If you'd like to try out Haskell, for example, I can really recommend this book, Learn Your Haskell for Great Good. It's a super, super smooth, super, super friendly introduction into Haskell and kind of functional programming in general. And one of the cool things about functional programming is that it feels very weird to program in, but once it clicks, it really clicks and it changes kind of how you think about programming in general. And yeah, that's it. Thank you. Yeah, I'd like to introduce, well, actually, before I introduce the next speaker, we have, I think, one question on Slack about functional programming. Denise asks, what's the most elegant and practical way to make sure that a function aborts at the right point with the right error message when input parameters are of the wrong types are supplied? There are two ways of doing this, I would say. Depending on whether you want this kind of error to happen at runtime or whether you want to catch it before you run the Python program. If you want to catch it before, I really recommend looking into type annotations, especially with MyPy. What these are is essentially they're a way of annotating what types a Python function expects to receive and what it expects to return. And then you can run an analysis tool on your Python code that tells you when you might be passing in things of the wrong type into your function, and that can help you. But otherwise, when it comes to aborting at runtime when you're getting arguments of the wrong type, I would maybe go for using assert functions. So in Python, you can do assert and then a condition that should be true, and then the program will fail if that condition isn't true at that point. So you could do assert type of argument is equal to integer or whatever you need, and if it isn't, then it will exit with whatever kind of message that you give after the assert. So yeah, I would maybe look into using asserts for that. Cool. Are there any more questions? Are there any questions in the Google? I don't think so. Okay, cool. So I would like to move on to our final speaker of the evening. Her name is Mridu Bhatnagar. She is a software engineer. She likes to contribute in building software, loves to pay it forward and give back to the community. And so I would like, without much further ado, to hand over to her. Take it away, Mridu.
Hello, everyone. Is my voice audible? Great. So, the topic of my presentation is basically memory address in Python. I'm Ridu. I'm Ridu Bhatnagar from India. I'm a software engineer. I have been working since last 2 years. And let's go ahead with the presentation. So, just let us start with what exactly do I mean when I say the term memory address in Python. So before we could go ahead with anything else, first let us understand what does it mean by memory address. So as we have learned that everything in Python is an object. Each object so everything in Python is an object, and each of these objects gets stored inside a memory. And the location where the object gets stored in memory is referred to as the memory address. So let us break things down from this statement and let us see what is happening under the hood. So I'll just try and show you with a diagram that what exactly I mean by that. Uh, so imagine this to be your memory, uh, right? And here this we can divide it in different parts. So I am dividing it in different parts, and let us see what is happening. We are trying to divide it. Uh, Let us again divide. Yeah, just a second. Yeah. So all you can see is this is a rectangle, and I have divided it into different parts. And you can imagine that one part is one object. So suppose I am initializing my list as, suppose I initialize my list, so I can just do, whenever I am doing L is equal to 1 or L is equal to 1, 2, 3, 4, you can imagine pictorially that how things are working. It means that this value is getting stored somewhere in memory, and memory I have represented by by a rectangle that you can see on your screens. So uh, the address of this rectangle would be the memory address. So memory address is nothing but each object when it gets stored in the memory, we are referring to its location by memory address. Moving ahead, the another term that I used was everything in Python is an object. So that might raise another question in your mind, that what exactly is an object? Why are you again and again saying everything in Python is an object? So the meaning is an object can be imagined as an entity, and it has some metadata named as attribute, while other associated functionality is called as method. These attributes and methods are accessed via dot syntax. So a simple example of this could be that your list can be an object. So in list, we know that there are different kinds of method already available to us. Like you already have methods like dot sort. Uh, you already have some methods like dot sort and other similar methods for list, append, extend. These methods are already available with list. So it is an object and you have some attributes associated with an object. What needs to be remembered is every object will have three particular things. That is, what is the object type, what is the object value, and third part is the identity of an object. So irrespective of what object you have, every object will have these three things which you have to remember. That is the value, its identity, value of the object, identity of the object, where it is getting stored. So these things are to be remembered and are very important. Moving ahead, how to determine memory address of an object. Now, we have been saying since the beginning that, okay, the talk is on memory address, and in Python, everything is an object. And we are storing these objects inside of a memory. So every object will have some address. But how we as a developer would know that what is the address? So in Python, you must have come across an function named as id. It takes in it takes in one parameter inside it, and that parameter is an object. So you can replace the object with string, integer, with any kind of string value, integer value, any iterable, and then you can determine what is the memory address. So id is a built-in function in Python. It accepts a single parameter and returns the identity. One thing to be remembered is that every object is going to have a unique identity. So let us just code and see what is the meaning of this ID. So I have a variable a and its value is 1. So the way assignment takes place in Python is first the object gets created and then we have a reference variable assigned to that object. So here that reference variable is a. And now I'm saying that ID is a built-in function that helps me in determining the memory address. So let us see how we can get the memory address. See, all we did was ID A and it returned me a unique memory address. Now let us try another example. I do a B, I did A is equal to 1, now I am doing B is equal to 1. Again, when I do B, when I do ID of B, I get another ID. So now what you can observe here is both the IDs returned are same. Now, does it make you question yourself that what exactly might be happening? Earlier I was saying that IDs need to be unique, but now we are seeing that IDs of both IDs are same. So now what we need to understand is in Python when we are we are assigning values to variable, we need to first understand that first the objects get created. So one is an object with integer object which has already got created in memory. And again we are doing b is equal to 1. That means we have only increased a reference variable. Earlier a was referencing to 1, now b is also referencing to the same memory object. Hence both the IDs are same. No new object has got created. One is single object in memory and A and B are just the variables which are referencing to that same memory address. That is the reason why you can see that both the IDs ID A and ID B both remain same. Moving ahead, uh, I hope the ID functionality has got cleared. So ID helps us in determining that what is the memory address of an object. And now this is a very known statement in Python. And if you are someone who is going to give interviews or the one who takes interviews, one very common fundamental question that is being asked is in Python, what are the data structures which are which are mutable and what are the data structures which are immutable? So now before answering that questions, first let us see that what are the data structures which are mutable. So as you can see the statement, objects of built-in type list, dictionary and sets are mutable. I'll repeat the statement, objects of built-in type list, dictionary and sets are mutable. Now this makes me again question myself that the statement seems to be fine, but what do you mean by the thing mutable? So what mutable means in plain English is changeable. So here in Python, what mutable means is we can change the content of these list, dictionary and set and still the memory address will be remaining same. Now before you believe on what I am saying, let us just try hands-on that what exactly is happening under the hood. Oh. As this is not my command prompt, the clear command did not work and we have again started. So when I do a is equal to, oops, sorry. Yeah, so we were trying to see that what do I mean when I say things are mutable. So I told list is mutable and I am doing an 1, 2, 3, 4. ID of L I do. And I have got, it has returned me a unique memory address. Now I realize that, oh, the list is containing only 1, 2, 3, 4 and I need to add 5 as well. So what I did was I just appended 5 to L. And I did again 1, 2, 3, 4, 5. And now let us again see what is the ID of L. We can see that the ID did not change. So as I had told in the beginning, mutable means in plain English that you can change something. Now mutable in Python refers to you can change the content of the object without the underlying object, without the underlying memory address being changed. So this example shows you that we have changed the content of the list, but still you are able to see the same memory address. Likewise, in same way, it works for dictionaries as well as sets. Another example which can be tried out is L is equal to, I do 1, 2, 3, 4. ID of L is this. Now what I want is the list L should get copied in L1 as well. So L1 and L should be same. So I just do L1 and L, and just we can see the contents of L1. The content of L1 is again 1, 2, 3, 4. But the big question to ask here is what is happening to the memory address? Now let us see what happened to the memory address. Any guesses on should it remain same, should it change, or you are expecting something and some Python magic is going to happen? See, what is happening is again the same memory address has got returned. So this tells us that both L1 and L are pointing to the same object. Now moving ahead from this example, now that we have understood what is the meaning of mutable, we can, I think, check one more example as well. Okay, I'll first cover immutability thing. So we just now understood that what is mutable, and so far the things we have discussed are in that what are objects, what is the meaning of memory address, how we can determine memory address. Then we discussed what exactly does it mean by list, dictionaries and sets are mutable. And now the next topic is, the next statement is this: objects of built-in type int, float, bool, string, tuple are immutable. Now immutable is easy to guess now that we have already discussed mutable. Immutable means the contents cannot, immutable in plain English means unchangeable. You cannot change it. Now in Python, it refers to you cannot change the content of these objects. If you change the content of these objects, the underlying memory address gets changed as well. So now let us see in code what is happening. I have a string with me and the string says PyLadies. Let us see what is the memory address of the string. So ID, as we had already learned, that ID helps us in determining the memory address. So it did what it always does. It returned me a memory address. But now what I want is I just want to modify the string, and I'm thinking of making the small p in PyLadies to capital P. Now let us see what happens. It raised an error. Now the error raised is type error. str object does not support item assignment. So this might make you remember that in strings are immutable and strings does not support item assignment. If I have to again, if I have to change anything in the string, I'll probably have to again construct a new string object, and then assign it to a reference variable. This did not work. And now let us see what is happening with the case of tuples. In the presentation, I said that even tuples are immutable. Now let us see. So here we are initializing a tuple, and as you might remember, tuples are initialized this way. So I do a k 1 2 3 4. Now I want that my tuple should also have a fifth element, that is 5. Now before I add a new element, let us see what is happening. If I do an id k, it returns me the memory address, and if I want to add a new element, just see that would the same methods work here. It raised an error. Tuple object has no attribute as append. So this way the append cannot work. There is no method as append in tuple. Does pop work? No, it again did not work because these methods are not present in tuple, and tuples are immutable. So you cannot make changes like these. And let us try assigning that. Can we assign something? If I do a k plus is equal to, and I want to extend this whole tuple. It did not raise an error, but let us see what has happened. K, it even added an element 5 to it. Now, but the question is the ID same? Now you can see the ID itself has got changed. So when the contents are changing, we can see the memory address is again changing. So this is something to be noticed when you say what is mutable in Python, what is immutable in Python, and under the hood what is happening. This is again one of the examples. And once again, so when I was dealing with all of this, out of curiosity, I did try this another thing as well. What would happen if my outer object is immutable, but the objects inside of the outer objects are all immutable? Sorry, inside reference objects are mutable, and outside one is immutable. So just showing it through code might make things easier. So what I do is I do a 3 4 5. Now based on what we have discussed earlier, we know that tuples are immutable. So you can see my outer object is a tuple, and we know that lists are mutable. So my inside reference object is a list. Now what I want is I want to extend this list. So the curiosity question is, would I be able to do that? First, let us check what is the reference ID of K. So reference ID of K is what got returned here. And now my objective is I should be able to extend this list and then see the output. Now first I'll have to see that what is the location in which this list is present. So as we count elements from 0, so it is 0, 1 and 2. So I do a k2 dot append. As it is a list, I can use append functionality, and then I add an element again. It worked. And now if I see k, I'm able to see that it has got changed to 1 2 3 4 5 6. Now let us check the ID. Now we can see that the ID also has remained the same. But there is a small difference, and if not thought of carefully, you might think that Python is doing some magic. Well, there is no magic here going on. What needs to be remembered is the object reference ID here has not got changed because we were appending an element to a mutable object. We added an element to the mutable reference object that was our list. We made no change to the outer tuple. I added no extra element to the outer tuple. I made a change in the internal in the reference object which was inside of the tuple, that is list. And in lists, as lists are mutable, we can make such changes. Hence, the memory reference ID did not change. But again, here is an interesting thing going on here. Again, if I do k is equal to 1, 2, 3, here I do 3, 4, 5, I do this, and I want to add again the elements to the list. I do k2. Instead of append, now I am using k plus equal to. Instead of append, now what I am doing is k plus is equal to, and I want to add 7 and 8 to it. It raised an error. Now, why did it raise an error? Because k2, because we know that in tuple item assignment is not possible, and k2 is a part of the tuple, and here I am trying to assign an element inside of a list using the assignment operator, so that won't just work, and hence the tuple raised an error. And so these are some of the interesting examples that you can play around it and play around with and see what is the behavior when you are working with different kinds of data structures, and also the cases where you are dealing with multiple data structures at the same time, like list inside of a tuple, dictionary inside of a list inside, and many more similar combinations. Moving ahead. Now, so far what we have dealt with is what is memory address in Python. Then we also know what is the meaning of object in Python. Then we understood what is meant by mutability in Python. Then we understood what is meant by immutability in Python. Then we did quite a lot of examples of seeing that what exactly is happening under the hood at the memory level. And if you connect all these dots backwards, you might remember that in Python, often you might have used is at some places and double equal to at some places. Now, the question is, when should we use is and when should we use double equal to's? Are these both same? Are these both different? So, based on whatever we learned, the answer is operator is used to compare the identities of an object, while double equal to compares the contents of an object. So quickly we can just do our last example probably. I have s is equal to 1. I have s1 is equal to 1. This was probably our first example. We can check the ID. Now we know that both the IDs are coming out to be same. So I can just do a check if s is s1. It returned us true. Now I can also do s is equal to s1 to check if the contents are same, and we see that what is returned is true. So now for all the examples that we dealt with since the beginning, you can try out using is and double equal to operator and see what is happening. Are we getting the correct results? And this would also give you an answer that what is to be used when. And another interesting question is, can memory references be copied? So by this copy, what I mean is in Python, if you remember, we have a star operator. It helps us in copying. It gives multiple copies to us. So for example, if I do s is equal to foo and just do a multiplied by 3, the expected output would be you are getting 3 times 3. Foo, foo, foo has come. But so similarly, let us see what this multiplication would be doing with the list. I have a list L. I do 0 multiplied by 3. And again I do 0 multiplied by 3. Now this list gives me this. So you can see that there is list inside of a list. And now if I do L0, L0, now the whole idea of this is I want to change the element at position 0, 0. So I want only that element to get changed. Now based on what I have learned so far, what I ended up doing was just casually doing L00 is equal to 1 because I had to replace that 0 with a 1. I did this. Now the output that I was expecting was okay, only that 00 element would get changed. But now Python being Python, it showed the magic. Instead of L00 getting changed, it also changed 01 and 02 got also changed. Sorry, 10 also got changed and 20 also got changed. Now this again led me to thinking that why does it behave the way it does? So just check out what is happening under the hood. What does that star operator do? Now that I know how to determine the memory address, I'll just do ID of L0. I then did ID of L1. And then I did ID of L2. Again the same memory address. So as you can see, it is not just like all the memory addresses have also got copied. All my 3 lists inside 3 sublists are having the same ID. So instead of only one element getting changed, you are able to see that multiple elements had got changed. So it is in times like this when you must, when knowing about memory always helps. Now that you are aware of memory, I hope this example did not appear to be a magic because we were knowing that how things are working under the hood. And if you go and check the ID of L00, you would see that ID of L00 is this. Now another element that has got changed is L10. Memory address here appears to be the same as well. And if I do a 20, it is the same here as well. So this star operator had copied the references. So this was another interesting fun example to deal with. So I would just like to summarize all that we discussed in today's talk. So we started off with what exactly does it mean when we say what is a memory address. Then we tried seeing pictorially that what exactly does it mean by storing an object in memory so that you could visualize things better. Then we understood that how to determine the memory object. So where id built-in function helped us. Then we saw what is mutable, what is meant by mutable, what is meant by immutable. We saw lots of examples of that. And then two confusing examples where the memory reference was getting copied and another was is versus equal to. So this brings me to the end of my talk, and thank you so much.
Woo, thank you.
Thank you.
I'm just going to see if we have any questions in the Slack or in the stream chat or in Google. Nothing in Google. Lots of people saying that their mind was blown by the same memory address. I think the first time I saw this as well, I was like, oh my God. Let's have a look.
Are there any questions that are there?
I can't see any questions. So, yeah, so if you're comfortable with that, we can say that's call that off. Just give it a last
Yeah,
minute.
sure.
Cool. Yeah, it doesn't look like there's any questions. But yeah, thank you so much, Mridu. That was a really, really illuminating and quite interesting talk. Lots of pitfalls around memory in Python.
Thank you so much.
Thanks.
Thank you. Thank you.
Cool. Yeah, so that brings it to the end of our event. I want to thank again both of our speakers for their wonderful talks and for dedicating their time to practicing this and getting this through. Finally, some kind of announcements. We would really love you if you gave us feedback on this workshop, especially since this is a kind of new, this is kind of like a new format for us. We would really love it if you gave us some feedback on how well you think Twitch works for this thing, for this kind of, I guess, series of talks, whether or not you'd prefer something more interactive or maybe like more kind of roundtable discussions, or if you have any suggestions of alternative tools or things we could maybe use to kind of facilitate these kind of talks and workshops online while we're still all stuck indoors because of the coronavirus. Again, if you'd like to register as a member of PyLadies, we have a URL here, bit.ly/PyLadies membership registration. Yeah, if you would like to get involved with coaching or helping us organize events or give talks or anything, please just get in contact with us. And lastly, again, if you're interested in learning more about Python, we can really recommend grabbing some tickets to the Remote Python Pizza on the 25th of April, which is not this Saturday, but the next Saturday, I believe. I think the CFP is closed for that, so I think the schedule is already full, but I'm not entirely sure. Yeah, I think that is it. So yes, thank you again to all our speakers. Thank you for everyone joining in and watching this on Twitch. And yeah, I guess we'll speak to you the next time we have our next event. Cool. Thank you. Bye.